So over the next 2 hours, hour and a half, I'm going to give you a good overview of many of the points that Keith highlighted yesterday in his PowerPoint. I'm going to dive in and actually show it to you in the software, okay? So let's get right into it. So to begin with, the TI portal, intuitive, efficient, proven. Those are the buzzwords that we launched this product. That the key things that this software needed to do. But at the end of the day, for you guys, intuitive, efficient, proven, how does that help you? So what I really want to try and show today is, how can this software save you time and money? Because ultimately that's what it's all about, reducing your engineering time. And I want to show concrete examples in the software where we think we can do that. Okay? And not only, but saving you time and money, but across the product life cycle of any product or project. So design, commissioning, and maintenance. What are the parts of this software that you can use to help you in those different phases? Okay, so let's start by looking at the design phase. There's a lot of stuff in here now in the portal where it was designed to help reduce that engineering time in that phase. But let's start by some open-ended questions. What are the problems that you, as an OEM, a system integrator, or an end user, what are the problems that you have to face? So how are you going to manage different software packages from different devices on the machine? How to manage the different disparate types of information in a control system, PLC logic, HMI, and drive parameterization. And how are you going to network different parts of the machine together if they need to communicate? Even if these are all from one vendor, never mind if you have components that are from different vendors, different parts, these are all problems that you kind of have to face. So for us, the solution, of course, and this is the big thing we talked about yesterday, the real advantage with the TI portal is, of course, the integration, and a real integration. And I'm going to show some of those examples later on. And in this slide here, you can see, okay, in one project, you can do micro PLCs, mid-range PLCs, our new S71500 controller, panels, HMI, SCADA, Profibus, Profibus, Profinet, PC-based systems, everything in here, even safety. It's coming with the version 12 in the summer, but you can do it now within the V12. So it's all in here. And so what is the value for you? So for us, we see easier data handling between devices in one project. We've had that feedback already. The tag handling between the PLC and the HMI is much easier when it's all inside one project. Easier to configure the network. So I'm going to do an example here of how you drop something in and how you connect up your different devices. And in this particular view here, this is an online snapshot of this particular PLC that I'm online with, and we give you diagnostics information. This is why you use this editor, and we're going to do it now in a minute, to rapidly configure and add devices in. When you go online, it's not just a dead static display. This comes alive with diagnostics information that you can double-click and it'll bring you to vault information for that. Okay? So without further ado, let me just jump right in, because I want to give you just an overview of the software, and we'll look at some of how these things integrate, and we'll add some items on the Profibus network. Okay, so again, we can make this interactive. Apologize ahead of front for the Irish accent. It's only going to get worse as I go along. So if you have any questions, get them in. We can back and forth. So no problems. And if you can't hear me, you have a question, throw something at me. We can stop. And we can make this as productive as possible. So inside the TI portal, we have two different views, and some of this might be redundant for some of you who are familiar with the software already, but what I want to try and do today is not only show you some of the highlights in the V12, but also kind of give a perspective. There's a lot of stuff that was in the V11 that's been out since 2010 that's still very, very, very important in regards to reducing your engineering time. So it's kind of a general overview, including the V12 stuff that's new. So when we start in the software, we have two views into the software. We have this view that you see in front of you here, we call it the portal view. This is a task-oriented view. Meaning, this was intended for first-time users, easy start into the software. What do you want to do? Configure a device, write a PLC program, add a HMI, parameterize a drive. Very simple. And in this particular example, I have a project already open that I'm going to work from. So I can look at these navigation tabs on the left-hand side for devices and networks. It shows me what's in my project here. For PLC programming, I can select a PLC, select a block, and from here you can jump right in. I can go to visualization, and for the selected panel, I can see the screens, the tags, and so on. I can use this view to work with. Also helps you with some online and diagnostics information, your installed software, and all the little movie clips, the little help guides for that Keith mentioned yesterday. They're all in this welcome tour here at the start. So these first, you have a welcome tour here, and so you can go in and look at them in here. So that's your reporting view. So that's if you're new to the software, you're going to start there. That's your first view. Of course, the main view is our project view. And this is our data view inside the software. So this is where you're going to work with for the majority of the time that you're using the software. So let me just give a quick layout of what you're looking at here. So, again, this is an existing project with a ton of stuff in here. And on the left-hand side, you see our project tree. And this is where all the data is associated for the devices that are in this project. So here's a bunch of PLCs, and I can open up this folder, and I see there's my blocks, my tags, alarms, and so on, they're all in there. I can open up my HMI screen or my HMI folder. Here I see the screen, there's one screen in here, the tags, and so on. So this is my, and of course what's new, and we'll talk about this a little bit more as well. Right, I have a G120 drive truly integrated into this project. What does that mean by that? I can open it up, and now I see here's all my editors that I can open up and launch for parameterizing my drive. So this is the big thing with V12. Not only obviously are we incorporating in the 1500 or new 1500 controller into the software, but now you can see PLC, HMI, and drive configuration all in one, and a consistent workflow between each three, or all three. So that's our project view. And then in the center then is our editor space, and this is our device and networks view here. And you can launch different, you can come over here and you can open up your blocks or HMIs, and this will open up in this space here. Then at the bottom we call this our inspector window, and this shows the properties info and diagnostics tab, and the properties then will update for whatever has the selection in the main editor view, whether it's a PLC, a tag, a HMI screen, an element on a HMI screen. Whatever you select in your view up here, the properties automatically updates to keep the information on that. So it's consistent across whatever editor happens to be up in the front, PLC, HMI, and then drives. Then we have an info tab here on the right here. And this gives you information to you, the user. Are you compiling? Do you have errors? What are your cross-reference? Okay? And then diagnostics, this tab will update with information when you go online, if there's a fault. Okay? So that's that area there. And then on the right-hand side, then we have our task card. And the important thing about the task card here, of course, in talking about the efficiency and workflow and so on, is that the task card will adapt. It will adapt to the editor in focus. Okay? So, so when we have the, if you see the task card here, so for example, I have the networks editor open. If I open up, I have a PLC block open up here, and you can see this opens up and adapts to show me the different instructions I have here. If I switch to the HMI screen, it adapts to show me the HMI elements that can be used in my program. So that's the basic layout of the software. And of course, these screens, you can collapse these, you can float the window, you can maximize it, you can dock it back in. As Keith was saying yesterday, you know, you can have multiple screens, you can float the different windows out, and the task card and everything is adaptable. You can auto-hide, it can go back in automatically by just clicking in here, or you can have it set so that, you know, you can set back when you want it to do it. So the Windows handling is quite flexible in this, okay? And then, of course, the new part, like we said, here in V12, we have then the, what's new, if I come up here and I go, let's say add new device, here's controllers, HMI, PC systems, and their drives. And if I was to add one of these drives from here, and I can browse through, and I can select a control unit and so on, if I pick one of those out of here, this will then appear in my project tree, and then I get these editors here, okay? So now, I have one of these editors open up already. And so, basically, those of you who are familiar with our starter software to talk about, to configure our drives, here basically, that those editors redone inside the portal. So we have a wizard view, two wizards, depending on if you're just working with the drive independently or you're controlling it from the 1500, you can step through those wizards to configure what's the motor you have connected out there, right? The basic motor data, so you can pull that in. So that's pretty easy. Additional functional view for some of the advanced parameters within the G120 drive, like for example here, I can go into my PID controller here, and there are nice masks and graphical illustrations of how you can use those functions. And if you're the expert of the drive and you just need to know a parameter number, then we have the parameter view. And here's all the parameters for the drive, and you can go in there and view it here. So these then, that's how the start drive looks and feels inside the port. Okay? But the big thing I wanted to get across here is look inside one project. Look at all the stuff I can do. HMI, PLC drives, and so on. Now, let's add something to the network here. So I'm going to come over here to this network down here. Because, so we go to hardware catalog, I'm just going to add some distributed I/O. Okay? So if I go to distributed I/O, and we'll say standard Profi net head module. So I can take, we'll say one of these out here, I can drag him out, drag and drop, put him into my network view, and I can double click, and you can see here, so we have a network view that is an overall view of everything that you've connected, but if you double click on any one of those devices, it brings you to the device view, and this is a photorealistic view, exactly what you see for the hardware, and then very easily the task card adapts to the editor and focus, so I can come over here and I can just very quickly drag and drop or double click, and I can configure easily enough this remote I/O station here. We'll just put some digital I/O in there, and that's fine. Now come back to my network view, and we'll zoom this out a little bit so I can see it a little better because I got a lot in here. So how would I connect that to my network? Well, very simple. I've got this PLC here, so I can just select the Ethernet port on here and drag and drop, draw the line, connect it to the port. And not only then does that put it onto that Ethernet subnet, this Profinet I/O head module is now assigned and works with that as controlled from that PLC. So the same way, I can drag in screens, I can drag in different PLCs, and just draw the line to connect up the different HMIs, panels, and things together. So that's, let me just see here. Yeah, that's pretty much everything. As far as the integration is concerned, that's one of the main points I wanted to get across. Again, a little bit redundant for some of you who are familiar with the software, but now you can see from that example what was, how the drive editors now look. And we're going to do a live, I'll go through it a little later and start from scratch to get the drive running. So what else is important for you in the design phase? So what are the requirements of a machine building industry? I've heard this said before that you need a serial machine. You want to build it once, and you want to copy it over and over and over again. Well, how are you going to manage one master project that has to be customized for different applications? Everybody wants it just a little bit different. Instead of living in an age of mass automation, we're living in an age of mass customization. And you, the OEM, or the end user, or the system integrator, you have to manage those projects. So how can the software help you do that? And this points here, this topic I'm bringing up here, refers to, for me, I think it's one of the most powerful features inside the software. Because the way, here's actually a very good question. How to reuse parts of a program that are shared across your company's product line. I have a small machine, a medium-sized machine, and the big-ass machine. And on those machines then, there may be a component, and it's the same. It's snapped on every time, independent of which product line is going out. It may have the same program block, the same HMI screen, the same I/O card, the same tags. So how could you easily encapsulate that and use it? And so that really is one of the most powerful features inside the software, and it refers to our global libraries. Okay, now what are they? So I mean, the global library is basically a folder over here that you can create, and it's where you can save that folder and what you can put in it, and the mix of what you can put in it that's the magic with the libraries. Because basically, you can drag and drop in here, you know, PLC, code, HMI, tags, anything you want into a folder. You can create subfolders. You can create hundreds of folders
for however way you want to subdivide your machine. But you can drag and drop one tag, or I can lasso this entire configuration and stick it in a folder. Completely flexible, how you want to do it. And so the idea being, you can develop parts of a project that can be shared across your company's product line. So let's see, how does this work? Okay, so over here then, I've got this library tab here, and we've got project libraries and global libraries. Project library is specific, as it says, to the open project, but I'm going to work with the global library for a moment. Because if I open up I'm going to create a global library, so we'll call it library 1, that's fine. And you can see here, this is where you can save it. This folder can be saved on your Office network, or your PG, or PC, whatever. But let's imagine, for argument's sake, I'm putting that in my Office network. So I'm going to create that library. And what it's going to do then, it's going to create down here, if you can see it, a types and a master copies folder. So now I can create subfolders under there if I want. But let's say this particular remote I/O station that we just created, let's say, you know what, I need that. So I can drag and drop that over there. Then I come back over to my code over here for argument's sake. You know what, I need that block, or I need that block. That block can come in here. So I need that block, and so on. I can drag over some tags. I can come down here to my HMI screen, and I can select here. We'll open this up, and I can take this screen, and I can drag and drop it over, and so on. You get the idea. I can build up a component or a part of a project, and then that's now saved on your Office network. Your colleague comes in the next day, he opens up the software on his laptop, browses for that library on your Office network, opens it up, and he'll see this same folder on his project when he opens it up. And he can drag and drop and take everything out of there that you've engineered. So let's say I drag and drop this I/O station back out, and if I double click, it went in exactly as we configured it. And this is very, very handy. A good example here is it's like for safety, right? You configure a safety I/O card, and it meets the exact SIL safety regulations it needs to meet. You parameterize it in the properties. You put it in the libraries. It's good. It's got the stamp on it. And therefore, anyone else then is for reusing that, your colleagues can just pull that out of the library, and they know, okay, this is configured exactly the way it needs to be. But that's just for that's for an I/O module. Again, tags, screens, technology objects, PLC, or I can lasso the entire configuration and put it in there. Completely flexible. And flexible is the key word there, right? You need to be flexible. And this is a tool that we think that can help you be flexible in your engineering, for your supporting different projects. Okay, so that's a big point. We think. And actually those 2 points right there, the global libraries, I mean, the customers who we have talked to, where we have success stories with, where they have said they've really reduced their engineering time, the first 2 points, the integration, the PLC and the HMI tag handling, and the global libraries, that's where they've really seen the reduction. Now with the V12, we're hoping that a year from now, once this product gets into the market, we're going to hear from the same customers, my PLC, my HMI, and my drive integration, it's all making my project and my handling much easier. Okay, so next point. Another problem, I'm in the design phase. How to scale between different devices depending on the customer's needs and not have to re-engineer the system. Keith mentioned this a little yesterday when he was switching from, I've got a 1511. Oh, it's not big enough. I need a 1516. Do I have to re-engineer all my work? No. Okay? This is for me, is a big, big feature in the software. In this particular example here, I select this particular HMI panel, and I need to change it. So I can go right mouse click, change device, and up comes a dialog, and I see a list on the left-hand side, what is my current device, and then I can browse for a replacement device, and it will replace the HMI panel, and I haven't lost any of my work. So this will work for the PLC or the HMI. So let's do it. So for argument's sake here now, let's go back to my network view here. I'll close some of these windows here because optimize my space here. So this particular panel here, HMI 2, let's take a look at this. In the project tree, if I open it up, it's got some screens. Open up this paint screen here, for example. As you can see, we did some heavy-duty HMI work on this screen here to get this to go. So it's a regular touchscreen panel. So now that this project goes out, it's fine. Next time, customer says, you know what, this panel, it's a dirty environment. The operator's got a glove. I can't use it. It's got to be a keypad. I need a keypad version. You need to change it. Can you do it for me? No problem. Come over here to my device and networks. Select the device. Right mouse click. Change device. Again, here you see the list of what's in my project. So I'm going to browse. I can come in here. We'll change this to, this is a 7-inch, so we'll change this to a keypad version. OK. Hit OK. In that dialog, if there was something that didn't match, like if you were scaling up or scaling down and you were losing ports or losing things, it would tell you that. But for the most part, now it's already put in there. You see the graphic updates to show you it. But most importantly, all of the work that was in here from my tags and my screens and so on, I have not lost this. And if I open up that paint screen again, here you can see it's updated to show it. Now it's got the keypad or the push buttons on either side. So scalability. And in the options menu for the HMIs, you can set it when you're scaling up and scaling down. How do you want the actual graphics to orientate as you're scaling? So have not lost any work for that. So that for me, that's a big point. And that's how you do it. Right mouse click, change device, and you're done. OK, now, what else can we do? So as a customer's system becomes more complex, how to make the software easier to use. This was something that, my time in Germany when we were working on this software, there were 3 things that German product management said to us this software has to do. Usability, usability, and usability. There was just, we had to get that, we had to fix that. So, and some of the features I'm going to show you next were designed with that in mind. What tools can engineering software provide to allow the user to work more efficiently? So this gets into the point where if you're really integrated into one software package, and I would take a close look, if you look at some of the competitor software out there, and you'll see this. I've been to many trade fairs over the last couple of years, and this is a wave that's coming. Integration. Everybody's going to be integrated. But if you take a closer look under the hood of just how well they're doing it, this now, for me, these next couple of points really highlight when something is really integrated. So for example, intelligent drag and drop. If you're going to have PLC and HMI inside one framework, you can't be launching different software. It has to look and feel the same, but you have to be able to work between them. So in all of the editors, whether it's PLC, HMI, or the device configuration, you can very easily drag and drop between the editors. So I can very easily write in an undefined tag here, drag it over to one of these points here, and it's defined. I can do that very easily. I can then take that tag and drag it up onto HMI. Done. So easily work between it, and I'm going to do that now in a minute. Once you have tags all over the place, that they're all over, one tag is maybe used many places on my PLC, and he's all over the place with different screens, and I need to go look for that tag, cross-reference. So we see in the cross-reference a link to all tags in all locations where they're used. If that's different software for your HMI and different software for your PLC, that's a difficult task to do, to try and find all those locations. And then, if you change it, you can rewire. Let's say, you know what, this tag, it shouldn't be here, it should be down here according to the schematic. I wired it wrong. No problem. You can rewire the function, and all references to that tag are automatically updated without a compile, without a save. Boom. Because it's a true database underneath the hood. It's a real integration. So let's show that, because that's, I think, actually an important feature in here. So we'll just use, and this works for across all the different PLCs. I'm just going to use this one right here, right now. So we'll open him up. Now, let's put in a line of code here. So very easy. And we made a lot of improvements in our ladder editor as far as drag and drop, keyboard shortcuts, and just making it easy for the user to very quickly, put it there, just move it around, that's fine. And then I can come down here. So just create a very simple latching circuit if you like. And then I'm going to browse for, we'll say, now you see the IntelliSense list that appears. This IntelliSense list is the same IntelliSense list that you're going to see across all 5 programming languages: LAD, FBD, statement lists, our graphic, and our textual editor, SCL. We show an icon at the beginning. Is it a tag? Or if you're in a textual editor, is it a keyword? We show the name, and then if it has a hard physical address for I/O, well, then we show that as well. So for start, so I just pick here, tag here, that's fine. So I can very easily, and then prox1, whatever, we'll just pick some here. Actually, you know what? That one now, I'm just going to create a new tag called, we'll say test. Test doesn't exist. It's not coming up on the list. It's just, right now, that's just some undefined text. Well, no problem. Right mouse click, define tag. You can define the tags on the fly. And for internal memory, the system takes care of that. You don't have to take care of the handling of the internal bits. If it's a physical I/O address you want to wire to, no problem. You can enter it in if you know it. But for the internal handling, you don't have to manage that. So here I am here. I've got my little code here. So now I'm like, I want to turn on this output. I look at the schematic. I don't really know what's the next available output that I can just create an output and just put it on the card. I'm not sure which one is free. Well, I can double-click on the device configuration. And, of course, we can zoom in here on this configuration. And we see, it's got to adjust it here. We can see here, we put the names of the tags right on the channel. And this is for the 300 or the 1500 or the 1200. We do all that. And then I can very easily split the views and double click here to optimize it. And now I can come in here and put, we'll say mixer 4. That's the next one that's there. And right now, as soon as I do that, again, it's just some undefined text. Well, I can select that tag and I can drag and drop and put it right on a channel here. And it's done. You can see it's automatically assigned. And now, if I go mixer 4 here, it's in my list. Boom, it's there. I haven't hit compile, I haven't hit save. It's automatically defined on the fly. Then, yep. Okay. I was told to stand. Sorry. Okay, so that's an easy way of programming. It's an easy way to get that in there. I can come back then to my block, and I can say, okay, well, if I want to drag that onto a HMI screen, well, no problem. I have a screen here. I can split the view, and I can take my mixer 4 tag, and I can drag him onto that screen as well. Done. Okay, so I can work between the different editors. And then I select, now I want to use, where are all the places where that tag is used? Well, I can select that tag, right mouse click, and go to cross-reference. Cross-reference opens up. Okay, now I'm told to sit down. All right. Thank you, Keith. Appreciate that. All right, where was I? Yes. So what I wanted to show here is that you can drag and drop the tags between the device view, the HMI, and then look at the cross-reference. The cross-reference opens up, and it shows you all the locations, and I can click on a link, and it brings me to where that's used in my PLC code, and I can come down here and click on the I/O link, or the link for the HMI, and it's used there. Okay. And now I get back to the other situation I had, where if I come here, I'm like, oh, you know what? This is in the wrong spot. I need to rewire it. So what would I do? I can come right mouse click to the same tag, right mouse click, rewire it because it needs to go to a different physical output on there. And we'll say 7.0, I think, is the output on there. And I can change it. And it's done. All references automatically updated. And again, right mouse click, go to my cross-reference information. Everything updates accordingly. I haven't lost because, it's symbolically based. And it jumps and it shows me all locations of there. So those are very, very couple of quick things. Defining tags, drag and drop between different editors, HMI, PLC, do a cross-reference, and do a rewiring. That took, a couple of seconds to do that. But try to do that with different software packages, just what I did, and that's not going to be that easy of a task. Okay, so that's, when we talk about a real integration, a deep that we spent, you don't even want to know how much money Siemens has spent developing this software. That's the deep integration that we're chasing after, okay? Because there's little nuggets of usability and little nuggets of efficiency you can come across when you do that. Next topic, still in the design phase. And now I want to move into this 1500, because what I showed you there already, that's all today now, V11, you have all that. So what programming innovations would allow you to work more efficiently? What new features in the software? How to easily configure and program motion applications. How are we going to do that? Well then, very quickly, the quick overview. So with the 1500, we have this with the 1200, but with the 1500, you now have a lot of new software features that the S71500 and 400 PLCs, they don't have. And so some of these here, okay, the calculate box, so where you can just put in an instruction and type in an expression, and most importantly, the data type handling, it doesn't matter. Short int, real, double int, whatever you want to do, you can mix and match the data types to create your little expression there as well. Okay, and then important feature here, okay, this just shows here the indirect addressing and ladder, a variable index in an array, so all that, you don't need to go to a textual STL language to do that. It's all in ladder and FBD to do your indirect addressing or pointing. So those are some of the key, we also have a 64 mega data block as well. Most importantly, so value to the customer, easier to use, easier to learn. Easy motion configuration and programming. Now, before we get in and do this, there's really two things I just wanted to highlight. When we talk about the 1500 and motion, it's the first step is easy configuration of getting these two things to talk. The data handling that has to happen between the PLC and the drive, setting that up so it's easy to do. The second thing then is the programming of the motion commands from the PLC. So that's easy to do. We use the standard PLC open blocks. What does that mean? It means there are blocks that have the same input and output pins from other vendors as well, but there's some really nice features in here that we've taken advantage of that just makes this easier to use. So let's get in here and take a look at this live. So we'll just close some of these things here. We're not using these anymore. Save this so I can have that. Okay, so come back up here to my 1500 PLC in the tree. Just close some of these things here. So inside the tree then, go to my network view and you can see here. So now I'm going to look at this network up here at the top. This is everything that's on this kit in front of me. And you can see I could have created a project that just had just this kit. But no, I said, okay, no problem. I had a good project that was working before. I could take that, exactly what I had, everything that was in here, and I just, from a library element, just brought in everything that was already done and working with this kit. Right? So just as a quick example, again, of the integration. So now, so inside the OB1 here, we can open this up. And actually, what I want to do is, 1 second here. 1 second. The first thing I want to show here is going to be, I think, this OB handling here, because I think this is a new feature that came in. Well, it's not new, but I think it's nice. So, with all our blocks, so if I go add new block, what are the blocks? So in Siemens, we have organizational blocks, and the organizational blocks, think of those as tasks. And if we look at this here, what are the tasks that we have to do? So you can put in a block, and it's very clearly labeled here. This block will be automatically called for different conditions, on startup, on a cyclic interrupt, on a hardware interrupt, if there's an alarm handling. So we have a whole bunch of tasks that you can choose to put your code in there, and they will be called based on the certain, like I said, a cyclic interrupt or a hardware interrupt or a fault handling or so on. And the other blocks then, these are our functions. Think of this as like a subroutine. And the function blocks then, these are the subroutines with memory. So you can reuse your code over and over and over again. Important then as well, we can, we've up to, for the function blocks here, you can add in, we have up to, the graph is in here, but we have up to 5, for the 300 PLCs, we have 5 programming languages: ladder, FBD, statementless, SCL, and graph. The graph will come for the 1500 with Service Pack 1, and that's why you're not seeing it here in this list. We have ladder, FBD, statementless, and SCL. So those are all complete IEC compliant languages that you can choose to program in. Now once I'm in here then, of course, you can see here I've got, again, the calculate box with implicit type conversion. And there's, if you can see that here, I can zoom up in here. Very easy. This is just an indexed, an array, a data block with an array, and I can pass in the variable, my index, I can pass that in, so that's very easy to do that. So ladder handling, much better improvements there. But one thing I want to talk to you about, though, is the SCL editor. And for me, there may be a case that you may not, ladder doesn't do it. It's not enough. It's not capable of doing what you need to do. With SCL, we've actually done a lot of improvements in this editor as far as it's no longer a text file, it's a block. And what I mean by it's a block, meaning that it's compiled and downloaded, and everything I showed you there earlier with the cross-reference and the rewiring of tags, that's now available in your SCL block. It's not just a dumb text editor that you had to export out, do your editing there, and then re-import it back in. You don't have to do that. You should be able to use do all your SCL high-level programming in this editor. And so what have we added here that's so nice? Well, very simple. We've got the code folding to collapse and extend parts of your code. We have favorites here, which put in if statements, case statements, and so on. Put those in, code templates to be put in. The handling is the same in a sense that, the interface of the block, the variables that you pass in, if you're calling it multiple times, that's the same as the other function blocks. You can drag and drop from the instruction task card back out in here. You select an if, the matching end if is highlighted. You select an open bracket, the matching closing bracket is highlighted. There's a whole ton of stuff in here, bookmarks, breakpoints that we did that really made this handling much better. But what I want to do right now, because I'm just going to go online with this 1500 PLC. It's here on the kit in front of me, and we'll take a look at this code. And I'm going to monitor this code here. Come on. Okay, so what we did here with the SCL, a very important thing that I think can really help in regards to reducing, if you're using SCL, and it's an efficient way to program. So first off, you see when we go online, you see all of the status indications come in to say, hey, everything is fine. We've no online-offline differences. We have no faults on the kit. Now, in this view here, one of the things we did, this little overlay that you see on the right-hand side here, this shows me the names of the variables in my code, and I can select on one. And we can see here for this particular, if actual value is greater than set point, I've got my actual value and my set point, it's highlighted, and we show those current values there. But most importantly, if it's a Boolean result, if it's an if or whatever, if the result of that is just a 1, is a 0 or a 1, is it true, is it false? The first thing we do is we put the result right there. So you're monitoring your code, you can very quickly see false, false, false. You don't even care about necessarily the values in these variables, because if the main if statement isn't true, none of that code has been executed. So I can very easily then come here and go right mouse click, modify, we'll modify this operand, we'll put a value of 10 in there, whatever. And now you can see, I can just click off this line. Now you can see, oh, I'm browsing this code. This if statement is true. Boom, straight away. Now I can click on the line. And we click when we select a variable in the code. Because remember, with SCL or textual languages, you could have 10, 15 variables going off to the left there on one line. So when we select the line, we show you kind of vertically here what the tags are, what the values are, but most importantly, is it true or false? So lots and lots and lots of small little things that we've done just to try and make it easier for you to program. All right, so we can go offline with this now because there's a bunch of other stuff here I want to get into. Okay, so let's go offline. I don't know how many of you use SCL, or in the past with Step 7 2010 Professional, or even like with some of the previous versions, if you bought Step 7 Basis 5.5, you didn't get SCL. Some of those were additional languages that came only with the full professional package. But now Graph, SCL, it's all integrated into the professional package. All right, so that's some programming innovations that we have. You know, also as well, there's a ton of things here as far as string instructions, extended instructions here. So basically, all the instructions you should need to help you program your application, they're all in here for the 1500. Now, we talk about easy motion configuration, and let's get into this topic, and how is this going to work? So, there's my code. So what I want to do is now is let's look at to see where exactly do I start. So in this project here, I've got this G120 drive here, and that's what you see added to this network here. This top network here is exactly what I have on this kit. So how did I do that? So what you would do, I would go add new device. And again, controller, HMI, PC system, same workflow. I would select the drive, come in here to my control units, select this control unit here. And then when I did that, in my program editor then, this G120 drive appeared with the different editors. And I could go through these editors that I showed you earlier here, and I could use the wizard to go through the motor. I'm going to do this a little live a little later. And I got my functional view and parameter view. So that's all in there. And then, like I showed earlier, the drive will appear here, and I just did the select the Ethernet port of the PLC and drag and drop it to here, and then that's connected. Okay, so I've added the drive in here. I've maybe gone through some of the wizards to help with the motor. I've connected to the PLC. The next part is what I really wanted to focus on here. How then to make the communication between this very, very easy, and how to program it from the 1500. So inside the PLC folder, we have what's known here as technology objects. Andrew Miller mentioned this a little bit yesterday in his presentation when he talked about we have technology objects added into our code. So when I add new object, I have a choice: motion control, PID, or some high-speed counting. Now for the motion control, what is this doing? This is adding the axis into my PLC, okay? So I'm going to add this axis, go through some parameterization, browse for this drive that I added, and that's all I have to do as far as getting the communications to go. So for the 1500, we have a speed TO or position TO. Some of you, if you want later, you can come up and look at this kit. I can do speed control or position control with the 1500 as well. We have an encoder on the back of this motor going into a terminal module, and that's going Profinet over to the 1500 over here. But for now, we just want to talk about the speed control, just open loop, a fan, a conveyor, whatever you want to do. So I can come up here, I can rename this my conveyor 1, whatever you want to do. And when I added that in there, I got these folders here. A speed axis, configuration, commissioning, and diagnostics. And let's open up the configuration editor here. So this is already configured, but what would happen is, and again, I'll do this a little later live all the way through from scratch. Here you can see, here's the drive, and we're using Profi drive, and all I needed to do is I needed to go and browse, well, what's the actual drive that you want this axis to control? So I would browse from it in my project. I would see a list here of all the drives that were added to my project. And once I selected that, that would be here. And then in this configuration, or this masks, these configuration editors, that was really the only mandatory step I had to do as far as telling it which drive are you talking to. Because if we look at the data exchange, the next one, the drive, the integrated drives, we automatically default to a telegram. What's the telegram? I don't know. Input, output, control word, status words. Which one should I do? There's hundreds of different telegrams. We've selected the telegram here that we think fits maybe the 80% use case that you need to get your drive to turn. You can always come back at a later point and modify that if you need more information going back and forth. But to begin with, to get you started, to get the motor turning, all of the defaults that the system puts in should be good enough for you. So that's the data exchange. We have some extended parameters then that you can take a look at as far as mechanics and limits, but for the most part, we can accept those defaults. Now, that has put an access into my system. Now, how am I going to actually control that? So like we said before, the programming for the motion with the 1500, we're taking advantage, we're going to use the, one second, optimize my screens here. we have motion control here in our task card, and these instructions, MC power, MC home, move velocity, move relative, these are the PLC, the standard PLC open blocks. So the first thing I need to do to get this to turn, I need to enable the drive, and then I need to give it a speed and a direction and so on. And all of these blocks do that. But the thing that I really want to draw your attention to, let's say the first thing we want to do, MC power will enable the drive. So I can drag and drop that block over here, and then I'm going to zoom this in so you can see this a little better, because this is really where this counts. We have an access pin on each one of those blocks. And so to enable the drive, I need to give it a push button on the kit that's going to, here's my signal, but the access pin says, well, which drive do you want me to enable? Well, no problem. We added a speed access over here. Again, I could have named that conveyor 1, conveyor 2. So I can take this from here and just drag and drop and put it right on the access pin. Or use the IntelliSense to type in the name of the access. Both work. And that's all I needed to do to get the data communication, the handling between the PLC and the drive to work. So if I look at the other instructions I have in here, MC reset is just to reset the drive, halt stops it, a scale, very simple scaling instruction. We have just a slider on the front of the kit going into an analog card. So we're using this as the speed input to the drive, the little slider. I've got a move velocity. And then what I really want to show here is this move jog. Because now, if I go online with this, so we're going to go online, we'll turn on the status. You see the task card updates now to show me if I'm online, task card now gives me this testing tab. What's relevant for me when I'm online? Oh, what's your PLC status? You're going to change your call environment. I'm going to talk about that later. Breakpoints or call hierarchy, whatever, when you're programming. But essentially, what I need to do, just close this for now, so I can come up to my MC, here's my MC power, and then I've got one input on the front of the kit here, the switch button 1. Very easy for me here. I come in here. That will enable the drive. You can hear the fan coming on. And then I can come down here. I don't actually have to have a lot of these instructions in here. I really just need one of these, like, for example, this MC move jog. So again, this is the axis I want to jog. And I just have a jog forward bit, a jog backward input pin, and a speed. Those 3 things, that's all I need to give it. So on the front of the kit then, I can jog it. I can change the different speed here. You can hear it speeding up, slowing down, stop, go the other way, speed up, slow down, so on. A little later, I'm going to do this whole thing from scratch with an empty project and just do it. But I just wanted to show you here, the real highlights are just the easy way to use the technology object, which is the axis in your project. And you can have up to 20 axes. Up to 20 axes you can have the 1500 can control. Important caveat now to understand with this V12 release is that this is a G120 drive, and in this particular release of V12 there is not any synchronized motion that will come in future versions. So gearing, virtual master, synchronized motion is not in this version here, but for if you have simple speed applications or even a position loop, I can do position control. Granted, it's not synchronized like with other axes, but for simple position control applications or speed control, a 1500 with a G120 drive, that's a real sweet spot as far as setting it up, communicating to it, and handling the data, and so on. Okay, so that's getting the drive to turn. So then, let's keep going then. There's a whole bunch of points here we want to talk about. So let's go back to our slides. All right, so we talked a lot there about the design phase. Hammered it home, right? Integration, library handling, scalability, improvements in program functionality, improvements in motion configuration. I'm past the design phase. I'm in the commissioning phase. I'm on the machine. I'm starting it up. How can the software help me then? Right? So what are the issues you have? So what features could help the user reduce this commissioning time or tuning the machine? How to help the user to debug problems with this code? How to help the user debug his program without having any hardware connected to it all? right? How am I going to do? Wouldn't it be great to be able to debug everything without having any hardware? Well, all of these questions we can do. We have tools to help you with these features in the portal. So the big one, of course, the new feature, and I'm going to do it live here now, is the trace feature in the commissioning. And like I said, the real good pilot customer we had, Burr Oak, up in Michigan, where they had a stamping press. They were feeding metal parts in, and they really, really used this trace feature. They were like just perfect pilot customer because it was very important for them as far as when their stamp was working to really know exactly how it was, where the cuts were being made. And so not only, so they were a big fan of that. They said it was easy to use, easy to set up. So I'm going to show that live and explain how this works. So this is a commissioning tool to help. Detailed comparison. I've got online, offline differences. Somebody made a change. I don't know. Where's the change? How do I find it? It's very easy as far as indications. You saw here the little green bubbles. Everything's okay. Well, if there's a difference in the code, you get your little Pepsi icon on your block, and that's an online, offline difference. And so you can start a detailed comparison, and we try to highlight it in the code graphically. Where is the difference? And then we give you a result at the bottom that you can hit the link, and it brings you to every difference in the code. So we're going to do that in a minute. And then, of course, no problem. Later, the other hardware that I have in my project that I don't have in this kit, I can simulate that 300 PLC and that panel that I don't have. I can simulate them offline without any hardware. So I'm going to do that in a minute now as well. So those are three things that we think can help in the commissioning phase and reduce your engineering time. So let's start with the trace feature, because I think this is definitely worth showing here. All right, so just so you know, what's new then in the V12 is a new trace editor here. You see it inside the PLC. This trace editor is also inside the drive editor here as well. So if you're only working with G120 drives, and that's all you have in your project, you also have this trace feature here. It's the same editor, we just have it in both places. So if I open this up, okay, it's coming. So what I have, there's three different trace configurations I have here in this project. And takes it a second, it should come up. But then I can download one, and basically what we did on the kit here as far as enabling the drive, giving it a direction, changing the speed, let's trace that, okay? So if I look at this now, so when I set it, first off, let's talk about how do you configure your trace. Actually, let me just adjust some of the spacing here, because I'm going to jump into the properties here, because the properties is where you actually configure it. So what I do is then, let me just come over here. So I can add, 1 second here, because I'm just optimizing the space, because this projector is screwing up my resolution. So I've got a trace here. I called it speed jog. And in the properties is where you would configure it. And this is where you would say, okay, well, what signals are you going to trace? Well, you can see here I'm going to trace my slider, my actual commanded speed, what is the actual speed it's going, and what are the push buttons in here that I'm using. So I can trace analog and Boolean variables together. Once I have that set up, then I come in here. Here's a list of the 3 different trace jobs I have here. Actually, there's one in the PLC right now. I'm just going to delete this out so you can see this. So what this is doing, and we can optimize our space here. So on the left-hand side here, down here, are 3 different trace jobs that I have configured. Now remember, sorry if you don't remember this from yesterday, the 1500 PLC can have 4 trace jobs running simultaneously in the PLC. Each trace job can have up to 16 different signals, so up to 64 signals at any one time. Offline over here, I mean, I'm online right now, but these are the traces that I've configured offline. I can have hundreds of traces. And this was one of the things that one of the pilot customer, Burr Oak, they said, oh, it's great that you can do 4 and up to 16, but what we really like is over here, when you configure your trace, I can configure hundreds, thousands of different traces that I can actually, at any time swap out what's in the PLC and put a new trace in. So once you have the trace configured as far as what I/O you have selected, and what sampling rate, and do you want to trigger. All of that's in the properties to configure, to set up. Then you download it to the PLC, yes, or just load it into the PLC. And then I can activate it, and then I can enable it here. And now you can see it's starting, and I'm just going to actually run around here and enable the drive. So we have some data coming in. So we'll change this here, change the different speeds, stop, go the other way. Now I have this configured to run for a sampling rate of, for 1 minute. I get like 6,000 samples every 10 milliseconds, so it's going to run for about a minute. And so it's recording down here. If I optimize the space here, you can see what we do is, so here's all the signals that I'm tracing. And then I can minimize that. And then in the trace editor itself, we split it. Here you see the analog variables and the Boolean variables. So there's my slider right. That's what I was changing the speed with. And now, after 1 minute, recording is complete. So now I can turn off this noisy drive. Stop. Disable it. So over 1 minute time span that I've selected, these two colors here, the blue and the purple, this particular drive is tuned really well. So you can see they're almost overlapping here. The red was the slider, and then the green and the blue, that was enabled. That was a switch button to enable the drive, and then the switch button to just change it, the actual, give it a direction. So now, what can we do with this? Well, I can come up here. Maybe I want to separate out so I can see here are the different analog signals. I can put in the bars here where you can see, okay, exactly when I change direction one way, you can see, you can match it up. Standard trace tools that you would imagine. I can very easily zoom in on a section of code, put it here, select that, zoom in, and then I can change the label to the other side, however way you want to do it. Now, if I'm happy with that trace, then I can come down here and I can say, okay, see the trace I have in my system? I want that offline. I have already one here, so that if I come over here to my PLC, and I'm going to go offline. If I go offline, of course, that trace is in the PLC, so that goes away then. But because I captured it offline, I can view it. So I can view all this data offline. And then I can very easily right mouse click, come here, and go, I can export that out. You can export it as a TT-REC file or a CSV file. So you can analyze that trace afterwards if that's what you want to do. Okay? So that's working with the trace feature. That's one of the big new features then coming in with the V12. So we talked about what else can we help you with in programming when you're doing in the commissioning phase. So I had a block of code here. Let's zoom out. Let's go to about here. And I'm going to go online. This should be the same. I should have a match with this code here. And I do. So I've got no difference. So everything is happy. All right? So I can come to this piece of code here, and I can make an edit. We'll say I'm going to change this to, I'll put a tag in there, my index. That's what I want. Select that. Now, automatically, you see as soon as I make the difference, I see the online-offline difference because I've now edited the offline code. So let's say you walk away or somebody puts this change in your PLC, doesn't save it, so they walk away, they go home. You come in the next day, you have your original code, you go online, you're like, oh, I got a difference, somebody modified it. But if this block, you can start a big cross-reference or a compare editor, but you can just, because you see the differences in this block, you can open up this block, and right here in the editor toolbar, you can start a detailed comparison. So when I can start a detailed comparison, that's going to ask me to close that down. That's OK. And then I can come in here, just optimize the space then. Close this. So I can see side-by-side comparison, and we can go down through the code and see where is the difference. So We show little icons on each network where a difference is, but you can very quickly click on the link here below, and that should bring you then to the difference. And then we try to highlight it. So we put a color highlight. Where is the difference on the network? Yet this network has a difference. You can very easily, you can collapse all your networks so you can see, oh, okay, this is the one that has a difference. Expand it up, go through it, or use the comparison result. So, and this compare editor has been updated now from V11 to V12, because now you can do libraries. Somebody has given you a library. You can bring from within the libraries or from the library elements, you can bring them out and do detailed comparison on those as well. You can also do detailed comparison offline to offline, not just online to offline, however way you want to do it. Okay, so now let's go offline with this. The other thing I talked about was, so I can use the trace to help me commission. You saw that. Some online tools here that show me some values where I have differences and tools that will help me with that. I can also simulate hardware I don't even have. So let's come down here to this PLC here. So let's say if I look at on this device and configuration view, so you can see it a little better. So what I want to do is, I have in this project here, this PLC and this HMI. I want to test that code out. I don't have it in front of me. What can I do? Well, I can select that PLC, and up on the main toolbar, and this kind of goes along to some of the usability as well. What I want to compile, what I want to download, what I want to upload is all based on the selection, what I have selected in my project tree. So if I want to simulate this PLC, I can select this PLC, and right up on the tree here, we have a simulate button. So I can start the simulation. That's going to start this little separate kind of PLC application running on the computer. It'll compile. We'll see if we have any errors. No errors. So I'm going to load that down there and finish. That's done. And now I can open up this block. This was the block that we edited at the start. Remember, I added some little code in here. And now I can just turn on my glasses. That will bring me online with the PLC, and it will also turn on the status for that block. And there we go. And I've got some values changing here for my tank levels. Okay, now I want to simulate the HMI. How would I do that? The same way, the same workflow. You can come down to your tree here. This is HMI 3. Select it in your project tree and go up and hit the same simulate button. So we can start that. That starts a simulator here. And now you can see here, I have running HMI code and running PLC code, and that is nothing what's on this kit, purely simulation from both. So that's a commissioning tool that we think that can really help save you time and money, which is all about. So we'll close this down. We'll go offline with this. Okay, now moving on then, because there's some really important points here I want to hit before we take a break. I'm in the maintenance phase. What's going to help me there? What are the tools of the software can help me here? So how to help the user reduce the machine downtime, right? Machine downtime, this is the really important part here. And how to help the user protect intellectual property. We're going to show you how you do that. But the big thing I want to discuss here is the machine downtime. So diagnostics. System diagnostics inside the 1500 are now integrated in, so there is no system diagnostic blocks that are generated, okay? It's built in. So for example, this screenshot shows I have a fault on this module. You see it in the project tree. You can expand which module has the fault. You can double click on the icon and it will bring you to the diagnostic buffer. Again, I can simulate the HMI panel, or I can actually view it on the real machine, and you can see the same consistent workflow or the methodology. How do we represent a fault? Showing you the modules with the red icon, the kind of list view. You see it here on the comfort panel. Comfort panel has a really nice control called System Diagnostics Control. You just take that out of your toolbox, drop it on your HMI screen, and you're done. You don't have to do any extra configuration. So all system-generated faults, like a short circuit, wire break, whatever, are automatically generated for you. So we'll take a look at that right now. And the know-how protection, of course, how that looks to really hide the code so that you don't lose your intellectual property. But let's do the system diagnostics. This is my favorite. Okay, so I'm going to come into device and configuration. I'm going to go back online here with this 1500 PLC we have in my project. Everything should be fat, dumb, and happy. Oh, that's why. Cancel. I need to turn off this simulation here. Nope. So I've turned off the simulation for the other project. So now I come to my 1500. Just want to go online with that. And we should see all green lights coming in here. Okay. Or do I have a difference? Let's see. I made it. Oh, of course. We made a change, right? We have our online offer comparison. So I can select that block and just download it. Make a quick change on there so everything's green. Download that block, consistent download, that's fine. Download it, done. There we go, everything's green. Wonderful. Now, let me zoom in here a little bit so you can see this a little bit better. On this top network, I have green icons, everything's happy. On this kit, I'm able to simulate a wire break. This is set up for one of these channels so you can see what happens. If I hit the wire break on this kit, a red LED comes in on the module here. The display updates, but look what the engineering did as well. So in the engineering, you see a fault indication on the PLC, and if I open up my local modules, here you see it. I can double click here, but what I want to do is I want to go into my photorealistic view of my 1500 backplane, because that should show me, I'm at 400 zoom here, I can zoom this out to about 100. And there you see, there's exactly what I was talking about. In my diagnostics view, I've got an error on here. I could click on there to bring me multiple ways to get you to the error text. But the easiest way for me is, well, I'm just going to click on this red icon on this module. And that opens up a diagnostics editor, a dedicated editor dealing with diagnostics. I can go to channel status. I've got an error. Go to channel diagnostics, channel number 2, wire break. Okay? So now, that's one way I can see it. What if my operator, this is the fastest way, I remember the guys in the automotive telling me this a couple of years ago, the fastest way for them to reduce their engineering downtime was to have a clear message on the operating system so you don't have to have a technician come down and hook up his laptop to do what I just did there. So this diagnostic control that's on the comfort panel, I can show it to you here, but none of you, maybe the guys in front row can see it, the rest of you can't. What would be an easier way for me to demonstrate this would be, of course, to simulate the HMI. So I can select the HMI here in my project tree, and I can simulate it. And now it's going to actually start the simulation, and it's going to go out and look at, now I'm not connected to soft PLC, it's connected to the real hardware. So I can go to diagnostics, and you can see here I've got a red LED. So I'm going to click on that. I can navigate down through it. And it shows me, and this is exactly, if I was to go through the screens here, you would see it exactly the same. So I can select, there's my fault, go one more down, analog input, slot 4, wire break. So I can see it there. So that's actually, very, very, I have not written any code to generate any system diagnostics faults. So it comes in the engineering, I see it in the comfort panel. I can close that now because we don't need that. I can also see it on the web server. I have a web server. I'm connected. This 1500 here has a web server on here. I connected to that. So I can come into this 1500, just go enter. Oh, and again, you're remote. You're up in your office or you're miles away. You can connect in at the web server, go to the diagnostic buffer, and it says incoming event, wire break. Wire break, rail 0, analog input module, slot, so it's rack 0, slot 4, and so on. So I can see it on my web server, and not to mention, of course, it goes without saying, we talked a lot about this yesterday at the event. You absolutely can see it on the display. You can come up afterwards and take a look at this. You can simulate this fault, and you can navigate through the windows, the menus there, and you see the very same message. Okay. How are we doing for time, Steve? Another 5 minutes? Okay, that should actually, it's a nice wrap up then, because the last thing we just wanted to mention was the security and the know-how protection and copy protection. Some of the things that's an important part for you guys as well. So how does this work? Well, I can just, first off, let me fix my error, so no problem, so it goes away. Turn off the short, this is just simulating an error, so I can fix that. Everything should update, everything's green, that's fine. You can see as well here on the task card for the online system, the cycle time. So you can really see what's your scan times and what your maximum scan time was. So you know, all tools, you're in an online and diagnostic buffer, task card updates to show you exactly what's important in that phase there. So now I'm going to go offline. Now, we talked about know-how protection. Know-how or protection of the code so no one can see it. It's very easy. You can go right mouse click and just go to know-how protection. And this brings up a dialog. Actually, before I even do that, let me open up my SCL block that I have here and close this so you can see what I'm talking about. Now, in the properties of a block, we have the copy protection. We also, or the know-how protection. The know-how protection is basically the people can't view your code. And we always had that, but what's absolutely a very, very important feature with the 1500 is the enhanced protection. So that if you download your code, somebody can't come along, upload it out, and view your code because it's encrypted when it goes down there. Okay? So that's that, and I'll show you that just very easy how to do it. The other thing here I want to mention, because it's easier to show in this dialog, is the copy protection. And copy protection, I don't know if you can see that there, is the binding of your code. And you've got two options here. You can bind it to the serial number of a memory card or the serial number of the CPU. And I think one of the questions we had yesterday, if you remember, was, oh, if I bind it to the CPU, what happens if that CPU dies? Yeah. What do? You would need to go into your code here and just modify it to a different CPU, or probably a lot of people will do, bind it to the memory card. That way, if the CPU dies, just send him a new memory card and he's good to go. All right? So this is where you would do that. You can multi-select the blocks and do the same thing in the properties. It works. You don't have to go to every single block to do it. And the know-how protection, if we just, you can come here. It's the same dialog that appears. Define a tag, or 1, 2, 3, whatever you want to make your password. And then what happens then, of course, is that the actual code then is hidden. So you can call that. I think the interface is still shown. That's okay. But the user will not be able to see any of the code. And if I close the block, and then if I try to reopen it, you can see I'm prompted for a password. And only if I know the password am I able then to open up that block. But important, again, is the encryption that's under the hood with that when it's downloaded to the 1500. Nobody's uploading that block and able to crack it open to see what's in there. Okay? And the last thing I'll talk about in regards to protection is, of course, the enhanced features we've added to the 1500 PLC in regards to access protection and manipulation. So where this is shown is in the 1500 then. We can go to we have a protection, where we have protection here. And those of you who are familiar with our software probably already know, we always had read and write access protection. But what's new here is they've added a new fourth level of protection, because with the current systems, if you had a HMI, even if you have with the current systems a know-how protection, or read-write protection, so nobody, if they try to access the PLC with the PG or whatever, they're prompted with the password and they can't change any of the code. You can set that up today. But if a HMI was connected to it, you can go to the HMI and you can change data on the data block all day long. All right? So what's new is this fourth level of protection here in regards to access protection. It means not even a HMI can connect and change data to the PLC unless it has a password to do it. And so that feature is only applicable then to the newer panels, because only the newer panels in the software have that feature where you would set up that password for those HMI panels if you have this higher level protection access added. Okay? So the last thing then, of course, but it's difficult to demonstrate here in software, is the improved manipulation against the replay attacks and password sniffing that they've added to the ports of the 1500. And we also have communication modules as well, where they have a VPN available, so you can, knock yourself out as far as the security is concerned. Let me just very quickly here, I know you're all dying for a coffee, I am too. So, in summary, saving you time and money, intuitive, efficient, proven, across the design, commissioning, and maintenance phase of a project. So intuitive, consistent look and feel, flexible layout, graphical network, it's the look and feel and the workflow is the same. In the efficiency, you saw a whole bunch of things there that I talked about. The key, of course, is the integration of PLC, HMI, and drive. Libraries, global libraries, I'm telling you, that global library feature is being driven by a large automotive company in Germany. And they see the global library feature as a way to manage large projects, especially when they're dealing with code from other vendors. There will be continuous enhancements made to the global library features like versioning and how to manage the blocks, because they see that as a way where I'm a large end user and I got blocks coming in from different people and I don't have time to go in and are they the right, or what's the version of the blocks. They see the libraries as a way to handle that and manage that and help them with that. So that's only going to expand. Integrated diagnostics, the motion is now in there with the 1500. Tag handling is much better. When the S drives come in 12.5. Right now, of course, with the technology object for the drives, you can actually you can go to the data block and you have the tag actual speed, velocity speed. But with the S drives come in, they will also have tags in their PLC as well. Trace function, cross-reference, everything we talked about here. And then proven, the scalability. You can migrate, you can scale code. I haven't had a chance to do it today, but you can scale between a 1200 and a 1500 or a 300 to a 1500 or back, depending on the code. Okay? Obviously, some of the brand new features that are in the 1500 can't go back to the 300, but for the most part, you can do a lot of the scalability, and everything migrates up. Okay, last slide in summary. The results, saving you time and money, we think we can save with this software up to 30% in your engineering time. That's everything I've tried to show you here. All of those highlight points, that's where we think we're getting at it, based on those concrete examples I've shown you. In the design phase, easy programming, reuse of data, and flexible machine configuration. In the commissioning phase, easy analysis of the data, commissioning tools, and of course, fast troubleshooting with machine faults. And in the maintenance phase, then again, diagnostics and fast access to diagnostics. And the whole thing then, 30% reduction in engineering time. All right, okay, so the next, what time are we here? Basically, for the next 10, 15 minutes, I'm just going to do a little walkthrough from scratch, just to see how quickly we can get this motor to turn, all right? So, I already just went in and I said, create a new project. Project 1, no problem. So now, what's the first thing I want to do? First thing I'm going to do is I'm going to configure a device. And I'm going to add new device. And I want a controller. So I want a 1500. And let's imagine now I just pull this out of the box. And I couldn't be bothered looking at the part number or whatever to try and go through the catalog and add it in. So we have an auto detect feature, which we can suck in. Basically you take it out of the box, you wire it up, and you can auto detect it in. So that's what I'm going to do. So what I'm going to add here is just an unspecified PLC. And again, you could do this, right? You would begin maybe with an unspecified PLC, start your programming with this, do your testing, or write your code, and then at the appropriate point, pick a PLC. And if it's the wrong one, what do? Change device, change to a different PLC, right? So, PLC 1, that's fine. So I'll come here, go add. Okay, so that adds the PLC in my project, puts me into the project view. See all my folders on the left-hand side here. That's my mouse. There we go. So all the projects here. So now it's just an empty shell, if you like. So right here, we have I could use the hardware catalog if I want and drop something in here, or I'm just going to use the detect feature. So the S71200 had this as well, so of course that's added to the 1500. And just to remember, everything that the S71200 has is also with the 1500, because the 1200 is nothing more than the baby brother. When we were developing and designing the 1500 or the 1200, you know, it was just a subset of a bigger 1500 that was coming. Okay, so I can just hit the detect button here. Let's see how far I'll get. So it's going to go out. It's going to look to see, okay, how are you going out from your PG? What's your interface? And so on the port. Okay, so it detected a PLC out there. So I can select that. And I'm going to bring that one in. You know, if there were multiple PLCs out there, I could pick from the list. In this particular case, it had the IP address because we'd already downloaded to it. But if it was taking it out of the box, it would just have the MAC address and I could pull it in as well. Okay, so now here it is. It comes into my project tree. Okay, so I want to take a look at maybe some of the properties area here. There's some nice things in here maybe we can take a look at that's worth mentioning. So auto detects in. So the web server feature that I showed you earlier, no problem. You can come down here to the web server. I can activate it, hit OK, and now that's done. You know, I can come in now further down here. I can come into the different levels, different access levels, and set up, you know, what you want to give for different people. But that's enough. So I can activate the web server. I can come here, let's say system and clock memory. Let's say I want to have some default bytes for my first scan. So we'll just take bytes, internal memory here, byte 101. You don't have to do this. I like just to come in to set these up so I have them in my program. I like to have these clock bytes here available because these are, you know, if I want to do a trace or something, these bytes are kind of handier. And now, so these will appear in the tag table with these tag names for the different system and clock bits that are here. I don't have to do that, but I kind of like to do it just to have them available in my program. And then here again, you can see the protection. Here you can see you can set up the different protection levels, how you want to do it, and the different passwords. Nice feature that's in here as well that's new at the 1500 is the power supply, the system power supply. Here you can see, maybe you can see that well enough, it gives you a summary of the power consumption for each of the devices that's on here. Okay, so that's kind of something new that's there at the 1500. That's nice. Now, what I want to do here for my short circuit, how did I enable, or the wire break that you saw before, I'm going to come to this analog module, go to its properties. I can go to channel 2, because that's where I have the set up on this kit. So I can come down here, and I'm going to set this up. Originally it's set for voltage. I can change this to current. I think it's current 4-wire transducer. That's what's on this kit, and it's 4 to 20 milliamps. That's what I'm going to set that up for. And then I can enable the wire break. I think that's all I have to do for that if I want to test the short circuit. Then, so now once that's done, let's say, here's a quick example. Okay, I configured this analog module. Now I've set it up, I've configured something in the properties for it. Now I want to put that in my global library. No problem. I can take this, I already created a global library from earlier today, testing it, there's library 1. Well, I can take this same module now, drop it in here, and I'm done. So that's how, you know, very easy to set up and configure the libraries. So now let me go back to my network view. Now the IP address that's on here was at 1, so that's fine. I don't have to change that. And you can come here, you can enable a view here that shows which IP addresses and Profinet addresses are on the kit, around the devices in your system. So what I want to do now is, before I download to the PLC, I have a local, I have distributed I/O station, and I have the where the encoder's coming in. So I have this ET200S distributed I/O head module, and I have this distributed IM module over here, where this is my counter module where the encoder is being wired in, and again that's going Profinet back over there. So on my network then, I could manually drag them in and configure them, but why would I do that when I can very easily come to A library. I have those things already pre-configured and done. So I'm going to open up a library that I have here. And in this library here, I've got these devices. And I can very easily, so the first one will bring in, I want to bring in the MP one. We'll drop him in. And then you can see here, if I double click on that, that's exactly what's on that kit side. So you see that, and that's fine. That actually, in the properties, is already set up. So set up for to take in the encoder. So now I can come over here. What did I do before? Select my Ethernet port, drag and drop that to there. So now that's assigned. Okay. Then, so it's on the subnet, it's assigned. Then I'll take the next, and you can see here, it took the Profinet address, or the IP address that it was put into the libraries with. So it remembered that when I pulled it back out. Okay? So when I download this, I shouldn't have any problems. And then we want to do the same for the SP module here. We dragged him out, put him there, and then of course we just want to do the same thing. Turn it off for a second. Drag and drop from the Ethernet port, put it on the port there, and that's done. And you can see then, I can enable again here, you can see, so I've got my Profinet, that's 3, that's 4, and the CPU is 1. Okay, so we can turn that off. And now, let's download. So select my PLC, and I'm going to download it. And you can see here in the download preview dialog, there's 3 parts to this. There's the part at the top, what are you downloading? This is what's offline on your laptop. Here you can tell it, how are you going out? Profinet, Profibus, MPI, and which port are you using? So you can use, this is where you do that. And then it goes out and it looks to see what's out there and it fills in this list of what it finds. And you can select, yes, I want to go to this PLC. Load. Compiles, we always do a compile before we download to make sure that there's no errors. Yeah, we can stop. We want to stop because we're just starting from scratch here. Stop the CPU. And I want a consistent download or a consistent download to all my text. So this is downloading everything. This takes a second. Oh, it's done. Finish. Restart. Okay, 0 errors, 0 warning. Walk around now to make sure I've got my kit. Yep, he's happy. He's green. He's green. He's green. Drive has a bus fault, right? Because he's not connected. We haven't hooked him up yet. And the panel, we've lost communication because it's a different project communicating to that now. Okay? So now, next thing I want to do is let's go add our drive, because this is really, the goal here is let's see how quickly we can get this motor to turn. So now, how did I add my hardware before? I could pull out the drive from the library. I have it in there. But in this case, I'm going to do it from scratch. So I can go add new device. And we go to our drives here. We'll select the G120. 1 second here, I've got stuff going on here. We want the first one, that's right. Make sure I pick the first one here. And it's this particular, that's the control unit for this particular kit. Select that. That's now going to add that, and it's going to put me in the device view for this drive. Because now I have to tell it which power module. And the power module on this, I believe it's a 340. Just let me double check. Yeah, it's this guy here. So I can drag him out. That's the power module. And then a couple of things I'm going to do here. So this drive was already downloaded to. It had a name and it had an IP address. So I'm going to come over here to the properties of this drive. Close this. And we'll go to the first one, and we'll change the name, because the name is important with Profinet Communications, to G120. And you see that name change up here. That's the name of the drive. And the Ethernet address, I'm just going to change that to 10. That was the port. That's the address that's already set up there. Now, I'm also, let's see, we have some diagnostics if we want ProfiDrive standard diagnostics. So the diagnostics that you saw me do from the wire break come into the display, come up on the panel, I can get my drive diagnostics over on my PLC display the same way. So I can enable all those Profi drive standard diagnostics to come back. So that's okay, so we'll select that. And then I don't have to do this at all, but if I take a look at the cyclic, the telegram, the communication, there's telegram 1. Again, we're not forcing you to go in and memorize your telegrams and pick which one. We just default to standard telegram 1, which would be enough just to test your wiring, make sure it's wired correctly, and then you can go back and change that later if you need more information going back and forth. Okay, so then let's go back to our network view. And for sure, what would the step be? Just connect to the 1500, put that on there. So now we have, so the G120, it's got its IP address. And now then, I'm going to go online with the drive and go through the commissioning so I can optimize the drive. I can optimize it at standstill so the parameters are exactly right. So I can come into my commissioning. I'm going to start my commissioning, and this is going to try and take me online with the drive. Look, same dialogue like you saw before, going online and downloading, exactly the same procedure. So it says, okay, how are you going to do it? I want to go Profinet, and this is the port on this computer that I want to go at, and that's there. So it's going to go out now, and it's going to look for that drive. It should fill it in on this list. So there it's found it. It already had the IP address 10, so that's okay. So we'll go online with the drive. And now we're online with the drive. Now it's going to open up that commissioning editor, and you can see there's some things then. Now we're going to go into the start drive world, if you like, inside the portal. So now I'm online with the drive, and I've gone through. So maybe the first thing I need to do, I'm going to go through this commissioning wizard to optimize my motor settings, okay? So I can go through that. So basically I'm going to step through this wizard, and I'm going to basically take all the defaults. There's a couple of things here I might change, but for the most part I'm going to accept all these defaults because it works. That's fine. I don't care about that. It's a 60 hertz. I am going to change it to 60 hertz. Next. And then, so here it's pulling out, it's looking at the data that's in the drive right now for the power, the current, the voltage. Yep, that's fine for me. For some reason. Yep. So I'm just going to go next for that. That's fine. Here there's some of the summary of some of the important speed data. Yep, that's fine, just to get it to turn. I'm not going to kill myself. Now what I am going to do though is I am going to do some motor testing. So I'm going to actually identify the motor data at standstill. So after I finish the commissioning and I go to the control panel and I enable the drive for the first time, it's going to go out and it's going to do a little kind of a synchronization. It's going to test, give it some current and see, okay, yep, this is the motor we have, looks good. Next, and then I'm finished. Done. So now it's checking that data. It's going to put that in. It's going to just, it's going to copy RAM to EEPROM. All right, so we went through the commissioning wizard to try and optimize our motor data. Now let's go to the control panel. And those of you who are familiar with our starter software, a lot of this is very similar. It's just updated now inside the portal world. So the first thing I'm going to do is I'm going to activate the control panel. This warns me. It says, yes, you're taking over control of the drive. That's fine. This takes a second for it just to do that. Once this is really taken over control, then I'll be able to enable the drive and do some testing. Come on. Takes it a second. Come on. Still doing it. Okay, so then, no, it's your fault, it's there. Okay, so now I'm going to, we're here. So first thing I'm going to do, so right now you can see the motor measurement is red, so now I'm going to turn the drive on. You hear that? It's going to do, now it's actually just shifting the motor a little bit. When this testing is finished, this LED will go off and then I'll be ready to just jog the motor. It takes about a minute or so to just make sure everything is optimized, the motor correctly. Once this is finished, then I can just put in a speed and jog it. And then I should know that, okay, okay, good. So I can set the drive here, turn it on. Now we can just give it a speed, let's say 1,000, and jog forward, jog backward. So pretty quick, right? From scratch, auto-detect the PLC, add in the drive, and just do the commissioning wizard to make sure now you're okay, the wiring's correct, everything's all set, did my little bench test. Now let's get it turning by controlling it from the PLC. So now I'm finished with this, so I can turn this off, reset, I don't need that on, and deactivate the manual control. Okay, and then I'm going to come over here, select my drive in the project tree, and I'm going to go offline. No, I don't care for that. And now, what was what was the next step? Anyone can imagine? So based on the previous discussion, I'm going to go to my technology objects. Let's make sure I'm in the right steps here. I can go to my technology objects, and I'm going to add the axis. So let's do that. I go add new object. Same dialog appears as we've shown before. Speed TO, that's what I'm going to do. Again, you can change this name to whatever you want. My conveyor 1. So I go hit OK. And that's going to give me a series of additional editors. So now here's my speed TO in my program. So now I can come, and you can see, look, I've got, so this is, if you like, the visual representation of what we have here. So here is the drive, there's the motor. And inside the PLC, we've got our technology object, or our axis, and then we're going to add our user program blocks to make this go. Okay, that's basically what we're setting up here. So the first thing that I need to do, I got one mandatory parameter, follow the red icons, and it's asking me to say, okay, so Profi drive is the type. What's your drive? Okay, so I can come here. There's the one drive that's in my project. Okay, it's just looking at my project right now. You would see a whole list more if there were more added to this project, but there's just one there. So I picked that, and then look, green and blue. That's the only mandatory parameter I have to change in here, because now if I look at the data exchange, there's my telegram. Again, I could change it if I cared to, but for just getting this motor to turn, I can accept a lot of the default limits, so on for here. So that's my axis is now configured. Now I'm going to go to my program blocks folder. I'm going to open up OB1. And he's empty right now. So I could go to my instructions and motion control and start pulling these in. Or I'm too lazy. I'm going to come back to my libraries folder, and I'm going to pull in these blocks because I have these already set up. So I'm going to pull in my speed control block, and I'm going to pull in some tags. So my speed control block that I already have done, I'll drop him in. He goes over there. I'll get my PLC tags to go along with that, drop them into my PLC tag folder, okay, drop them in. And now, if I open up the control, what I've done here is, the block I showed you earlier and I had it running, it's the same block, but I've removed the axis pin here so you can really see, how this is going to work. So I can zoom in on that, close that. You guys see that okay? So you can see here, MC power, that's going to enable my drive. First thing it needs is the axis. Well, which axis? Well, the one we just added here. I can take that, I can drag and drop it over and put it on the pin, done. That is what I was referring to earlier as the handshaking, the data commune handshaking between the PLC and the drive. I don't need to know which bit of the control word to do this. All I need to know is use these instructions to say, this is the axis. Which switch in my kit, I'm going to use switch 1 to enable the drive, and then we'll just turn on the light here to do that. Everything else in this block is exactly as we had it before, and I have the tags, I just pulled them in with the block. So now, I should just be able to download this. Oh, no, of course, forgot, stupid me, I need to call the block. So I go to OB1, select my block here, call it an OB1, so that code is called. And now, I'm going to then select here and download. Just going to do a quick compile. Make sure everything's okay. Yeah. Load it in. I could have selected just the blocks there. I'd selected the PLC itself. So I'm downloading the hardware again. Didn't need to do that. So now, how would I look at my code? There's my speed control block. I can double click here, opens up the code. Now I'm going to go online, turns on the status of the block, brings me online with the code. Minimize that down here. First thing I need to do, like we did before, that enables the drive. You can see the true bit coming on. You can hear the fan going. And I'm going to scroll down to my... in reality, I only really needed 2 blocks here. This MC power block to enable the drive, and this one of these, move velocity or MC move jog to just actually get it to turn. See, there's my move jog. So there's my axis, jog forward, jog backward, gave it a speed. And the speed is just coming in from the slider and the analog that I have in the kit. Lo and behold, it runs. Speed up, slow down, done. Turn it off. All right? So, that is 11:30. I can keep going. He's telling me to stop. I could keep going there. I could now add in the HMI wizard that Keith showed yesterday, drag this wizard in, pull in a screen. Normally that's what I have. All the screens that I had on here, I have them in the library. I could pull them in and I can connect HMI, PLC, and drives very quickly. Okay? Before I finish, any real important questions now? Or did I bore you to tears? Sorry about that. Go ahead.
When you have all the PLCs and HMIs in one project, how do you manage multiple developers, programmers?
Offline, right. Offline, the way to do that is with the global libraries, like we just talked earlier. Offline. That's how you can bring them in together. So, they would work independently and then merge them together at some point. That's a manual process to merge your PLC and HMI stuff offline. Online, to have multiple users being online at the same time, that's a feature that's not in the software now, but it is one of the most important features that we recognize needs to come in a future release. The multi-user. Anybody else? Any questions? Go ahead. CFC is on the roadmap as well. That will come in a future version. I've already seen the designs for how the CFC works within the portal. It looks pretty good. So it's just a question of time before that's brought in. Like all the PCS7 stuff, that will come over time in future versions. Not in the next release, version 12.5. Not sure about CFC. That might come in as a standalone programming language. So you could do, ladder, FBD, or CFC if that's what you wanted to do. And the PCS7 stuff will come in later versions after 12.5.
So are you saying that somewhere down the road then the people that have PCS7
That is the current plan. Somewhere down the road, the whole goal here with this is that to have everything integrated into one package. So at some point, yes. Go ahead.
So people that have existing current PCS7 projects will be able to move that over into this.
That is the plan. But it is that is not, it's more than 1 year away before we're there for that. Any other questions?
Semicode will be this year?
Semicode is coming in Service Pack 1. So, and I encourage any of you, get your, buy your SUSs, right? Because with SUSs, that you should get the version 12 Service Pack 1 will come in the summertime. And safety will come with that. If you're using safety applications and you want to take advantage of safety in V12, you need the V12 Service Pack 1 and the V12 safety. So I'm thinking early July period before we see that.
Both Profibus and Profinet?
Yes. Yep. Yeah.
What
What
that means?
that means is that there is currently we have a software to handle the motor starters. I guess what exactly the Semicode. Right. That software right now, you can actually start it in the portal now, but when you start it, it has the classic look and feel of that software as it exists today. With version 12 Service Pack 1, all the software to configure the semicode can be started just like you saw here with the start drive. It'll have the same look and feel as the portal.
And just
the editors.
Just to add to that, what I'm hearing is that it's going to be revamped, made a lot easier to use.
Yeah.
It's not going to be Semicode ES in it. It's going to be something new, that functions something like Semicode ES, but a whole lot more intuitive.
Will it be able to handle Semicode Pro and Semicode DP?
That I would have to check with my CE colleague on that, but I.
Will it be able to handle Semicode Pro and Semicode DP?
We can check. We'd have to get back to you and check on that, but I'm pretty.
Probably got 6,000 more DPs out the field.
John Burns, we can help you with that. Yeah. Anyone else? Or then, before I pass over to my DT colleague, go ahead.
S120 drives.
S120 drives. Yes, the first, not all of them, but the first series of S120 drives, and there's our drive colleague coming now, can elaborate on this. The first of the S120 drives will come in V12.5. How many and which ones, I'm not sure at this point.
What about the wonderful technology for
That I would have to check. I'm sure if it's part of if it's coming in. I mean, I've seen the designs for the S120. It looks really good as far as, how the S120 drives are going to look in the project tree, photorealistic view, tags in the drives, being able to take a tag of the S120 drive and just drag and drop that right up to a HMI screen. So there's a lot there coming with the S1, but it's not all coming in 12.5. I think the rest will come later after that.
And the technology functions that you currently have are done in the PLC, not in the drive, for this motion.
Well, there are technology functions in both.
What you showed us was...
What I showed you right here today was everything was done in the PLC. Correct.